Welcome to the Databricks Lakehouse session. My name is Mustafa. I'm with Cyber. This is the high level, basically agenda. So we will be talking about Lakehouse, and Subbu will be showing how does the Lakehouse works, and then we will have Conrad from Matillion, who will be talking about how to bring the data in the Lakehouse, and then Cyber will be showing you some of the successes which we have done in moving basically customers from the on-prem warehouse to the Lakehouses. So just to let you know, so today we will have Subbu from Databricks, who will be talking about Lakehouse, and then we have Angel Conrad, who will be who is from Matillion, who will be showing how to move data from your basically on-prem to the Lakehouse. So just a high-level overview about us, who we are. So Cyber is Matillion and also a Databricks business partner. We are in business for the last 20 plus years. We are about 1800 plus employees worldwide. We are an ISO certified company. We are also Chicago Best and Brightest for the past couple of years. So just let's come directly to the main point, that why are we here right today? So if you see in the past couple of years, these companies like Microsoft, Amazon, Facebook, Google, why they have succeeded so much. So I think what they figured out that some of the things like data analytics and basically AI, they are currently running in silos, right? So they figured out that if we can somehow combine all of these three things into one, then they can do something really, really good. Okay, so coming to this, in the next 5 years, you will see that most of the companies who can somehow successfully combine, data analytics and also AI, they will be successful. And those companies who cannot combine data analytics and AI in one platform, they will left behind. Okay, so the question is that where are you in your data analytics and the AI journey? So we work with a lot of different companies, right? And what we have seen is that most of the companies, they are currently in the hindsight, that they have reports which they have made, which basically tells them that what happened. They want to go to the level of predictive modeling or descriptive analytics, and finally to the automated decision making. So they want to go from what happened to what will happen, how should we respond, and then finally automatically make the best decision. Lakehouse is one of the solutions by which you can go from hindsight to foresight. So I will now pass to Subbu, and Subbu will tell you how Lakehouse works and how you can go from hindsight to foresight.
All right, thank you. So thank you for making it. Appreciate all of you spending time. My name is Subramanian. You can call me Subbu. I run a small team at Databricks of solution architects. Our mission is very simple. Our mission is to make our partners successful. And we make them successful if our customers are successful. Simple, right? And so we do whatever it takes, from enablement to helping drive success in projects. So sell more, deliver more effectively, right? This talk now is all about, I have 40 minutes of prepared content. It's very tight, I'll be honest, because the platform can do so much. So feel free to ask me questions. We'll do 40 minutes. I'll take questions. We got some more time for Matillion to show an awesome demo. And of course, you can catch me at the end of it. Happy to take questions, right? let's keep it interactive. I have an interesting little activity for you guys, and we go from there. Now, before I jump in, how many of you folks know about Databricks? Hands, show of hands. All right, super. How many of you know about Spark and stuff? Okay, good. So I know what baseline to work with, right? Okay, so what are we? Databricks is a we call ourselves a data and AI company, right? We're about, if you know Apache Spark is about 10 years old. 2010 or so, it became an open source project. Back then, if you had lots of data and you had to compute lots of data, there was only one option that could do it. Hadoop was the option, and then Spark came on the line on the radar, and suddenly broke all records. Okay, and the world took notice. Like, what is this thing? Like, this bunch of 3-4 guys in Berkeley made this little script which could, sort 100 terabytes of data in like minutes, right? Their minds blown. 10 years on, those 7 individuals who founded the open source Spark Apache, they are still with the company. So Databricks is the same people who founded Spark then stayed on. They gave away the first version of Spark, open source, completely free. Then they said, okay, what can we do? How can we make money and take it forward? They formed Databricks with a vision of making Spark easy on the cloud. We are 100% cloud native, and we have moved way beyond Spark, okay? And we come to a point where we have invented multiple things, Delta Lake, ML Flow, we talked about it. We are in pretty much all over the place, right? Thousands of customers, every conceivable industry uses Databricks within, inside, in some form or the other, and that's only the beginning. Like there is the world left to conquer. Okay. Now, for this, so with that stage set, let's quickly talk about what Lakehouse is. I'll do a quick activity of, is Lakehouse a fit for you? Because let's face it, there's a lot of noise around this. So we figure it out. We do a small exercise, and then some more talking points on how to pick the right lake house. Okay, because there are imposters out there. I call them fake houses, by the way, trademark. Okay, so we'll get there. So let's go to the first one. What's the lake house? Now, to what Mustafa said earlier, right? The world has changed fundamentally. About 10 years ago, Netflix had the first example of machine learning was when Netflix had a contest saying, hey, can you build a recommendation engine? The team that can build the first recommendation engine will give $1 million to them. All right? That was ML, 10 years ago. What's happened since then, in the past 5 years or 6 years, has been only a few companies cracked it. You saw it on Mustafa's slide. The Metas and the Googles, they cracked it and they became massive companies, right? But what about the rest? Everybody has to get on the board, otherwise you're going to be killed the way the industry is moving. How many folks have seen what ChatGPT can do? Look it up. It is mind-blowing, ChatGPT, okay? It's built up by OpenAI. It's a natural language generating engine. Tremendous. So that's how fast things are moving. Now, how can a company like, even a smaller company which cannot afford Google salaries, how do they get on board this AI/ML thing? That's what the mission is, right? So you saw a similar slide in Mustafa's thing. There is this big push towards getting into the AI/ML side where the machine predicts what's going to happen, tells you what you should do, not just what happened in the back, right? Make the best decision and go for it. This has been, I'm going to skip a few slides because, in the interest of time, but we see these everywhere, right? From Goldman Sachs, for example, in seconds, if you put in, if you look at the Apple card, I have one, you do your application in your iPhone, minutes, it tells you are you approved or not, right? One of my favorite ones is, it's not on this thing here, is Comcast. If you're speaking to Comcast remote and say, hey, Comcast, play some channel, that voice transcription happens on Databricks clusters in the back. Massive scale, right? It's everywhere. So every company wants to do it, and it's challenging. It's not easy at all. It requires teams of PhDs and masters in data science and whatnot right now. We want to break that. And the reason why it's so difficult is because there are two different worlds, two different universes, basically, required to make this happen. There is the world of analytics, which is the current world, which is a very data warehouse-centric world, engineering analytics. You do your transformations in SQL and whatever, DBT or data stage or whatever, and then you put it in a gold table, and then you run BI reports after it. That's this side. Okay. The other world, of course, is the modeling. You want to run experiments on it. That's all in the data lake side typically. Because guess what? Can you do anything, any data science work in SQL? No. SQL is a lingua franca of warehouses. It sucks for anything other than query. Okay? You want to do programming, you go to bust out Python, Scala, Java, R, right? So that's why the two worlds have always been separate. And because of this divide that's been there, how do we patch things together? Anybody who's done delivery in any medium to large size company knows what I'm talking about. You build pipelines, right? You build hundreds of pipelines, and then you maintain two big copies of data. One big copy in data warehouse, one big copy in data lake. And now when you have two big copies of data, what are you going to do? You have to now start syncing them together. Reconciliation processes and error management. And then very soon, what's began like a simple project now requires a team of hundreds of people to constantly monitor drift between data sets and all sorts of extra work, right? So we call it data silos. Now you have two copies of data, sensitive data in there. How do you keep track of who's seeing what? Everything's got to be done twice. You put controls in warehouse, you put controls in lake. They're very different systems, right? So again, challenges. And then finally, I talked about the tooling. Tooling for BI is completely different from tooling for ML. So different tool sets, different skills, different platforms. All of this is it's too much work, okay, honestly. And it distracts companies from achieving the potential because they're so busy in just, dealing with the low-level bullshit, to be honest. Now, so what happens basically is this. The solution was, how can we unify all of this? Is there a way to bring both BI and AI/ML on one platform? And we have been thinking about this for a while. And finally, we had the epiphany that we can do this. And the bedrock of that was a product called Data Lake, which basically said, I can have all my data in one place, the lake, okay? Which is essentially what? What is a lake? Lake is S3 or ADLS or Google Storage, right? Which is a bunch of files. But then the question comes, but databases are very different. Databases are highly structured, data sets. They're highly optimized. How do you do that in a lake? Delta Lake solves that, okay? And by doing that, by becoming the bedrock of the new architecture, Delta Lake essentially, we built this thing called Lakehouse, which is Delta Lake at the very bottom, and then we have Databricks as the overall compute layer with all the capabilities in one place. And that's what Lakehouse is all about. So fundamentally, Lakehouse is one copy of data, source of truth, sitting on the lake with the guarantees and the performance that a data warehouse gives you. Okay? Now, and you'll see this multiple times, okay? But today my hope is I'll help you understand a little deeper on what this means. Okay? So because because Lakehouse is built on Databricks, and Lakehouse is a generic concept. It can go. It's multi-cloud, because we are on all three clouds. It is 100% open source. So Databricks, we invented Spark, we still maintain Spark, all right? 70% of commits to Spark come from our team. We pay for the engineers, right? And we keep giving it away. Amazon, Synapse, Cosmos, what's the thing on Google? Not BigQuery, the Dataproc. They all use open source Spark. Do we get paid a cent? No. Right? We give it away. So we coexist with our, we compete with our own product, so to speak. Okay? But that's fine. We are all about openness. Okay? And then finally, we talk about simple, and you'll see why, because we simplify. One platform, you learn one tool, you can switch your persona from ML to data engineering to analytics. Okay? We'll go into that. And this is what it looks like essentially, right? You have your stack. No stack is complete without partner support. That's another big thing we do. So on one hand, we have a host of third-party ISV products. Matillion's a great example. We are an investor in Matillion, right?
Yes.
Yes. So we love Matillion. Matillion loves Databricks, and we are strategically investing in a bunch of other companies that you'll see here, right? So we have a fantastic ecosystem. We have amazing integration with first-party services, and of course, our partners are the big thing. We have thousands of partners. I've only picked like 6 in here. Alzheimer's should be on that too. But you get the point, right? And like I said, we have all three clouds at this point. And because the platform is so flexible, it can do so many different things, we are pretty much everywhere, right? And feel catch me later, and depending on what your use case is, I can give you more specific examples. So Disney, for example, is a big streaming customer. If you go on Disney Plus and you try to, for example, you're signing up, all that sign-up process, setting up your account, all that happens on Databricks clusters in the back. And this is a very interesting case because when this first came, there was this, the sign-up load varies significantly during the day. And that's the streaming challenge. How do you optimize your costs? You don't want to keep a fat cluster running all day long, right? So a number of things were done, optimizations were done to make it cost effective. And essentially, the recommendations now are through Databricks clusters, the signups are through clusters, the analytics on the who's watching what is on Databricks clusters, right? This is the Apple Card example. I'm going to skip it. Now, let's do the exercise. So, is Lakehouse of inferior? Okay. So, I gave a quick glimpse of Lakehouse. Now, the reason I'm doing this is because you must have heard this proverb, right? That when something new comes, what do the competitors do? What's the first thing they do? They fight you, right? They can't fight you. What do they do then? They try to copy you, okay? And the third, and if they can't copy you, they join you, right? So we are seeing a bit of that happening, and right now we are firmly in that copy phase. A lot of folks are copying us, right? So this exercise right now is to see if it's a good fit for you. And this should be, it's a simple, I'm keeping it tight. 7 questions. Yes, no. Or that's all you're going to say, all right? So, yes or no, I'll ask the question, I'll give you some considerations how to think about it, and we go from there. So, first thing, right? Let's say you're a client. Let's role play this. You're a customer. You want to modernize your data estate. Your whole thing is an on-prem setup. It's capacity constrained. People can't run their reports on time, right? You want to fix that. Do you want an architecture? You're going to spend a bunch of money to rehaul it, to modernize data estate. So, do you want an architecture which can scale as fast as your data? Is the first question. Yes. Right? Nobody's going to say no. Yes. Common sense. And then I put this, right, which is data is doubling, tripling year on year. 5 years is going to be 32x, 40x, 50x. Whatever choices you make now must work 5 years down the line. And that's the way I always advise my partners and customers to think. 5 years down, it's got to work. Okay? If you have any concerns, have a backup plan. Okay? Second, do you want native support for future use cases? Analytics is current use case. Everybody has analytics use cases. Necessary to keep the lights on. Future use cases, AIML, data governance. Is there a path to get there? Now, a lot of folks will say, oh, we support it, but it's through a bolt-on, it's through a third-party product. You want native. Because minute bolt-ons come complexity, risk. So native. So do you want native support? Is the first question. Yes. Number 2. Do you want an architecture which is ready for a streaming future? Vast majority of folks, thanks to old school SQL-based transforms, are end-of-day batch. Companies want immediate results. I want real-time dashboards, right? 5-minute insights. Point of sale, by the time the guy walks out the store, they get a coupon, right? Actually, CVS is a great example. The minute you buy something, you get this foot-long receipt, right? With coupon. That's like real-time coupons coming in you. That's all streaming use cases. Everybody wants streaming, right? So, if you were in SQL, how do you do streaming? Can you do streaming in SQL? It's difficult, right? You have to rip the whole thing out. There's complexity in streaming. It's not easy, I believe. But, so, I won't reveal too much, but the point is, yes, if you go with the conventional architecture, it will be a rip and replace, expensive. So you want something which is not a rip and replace. You want performance? You want performance? Obviously, hell yes, right? Do you want price performance? Performance at what cost, right?
Definitely.
Of course, I want it to be cheap now and 5 years down the line. Next, you do my point on SQL. You did things in one way in the past. Do you want to do things in a better way in the future? You're buying a car today. Do you want the new car to be as exactly like your old car? No, we all want it to be nicer and shinier and quieter and go do that, right? In a programmer world, why should I be locked into doing things in SQL? I want to use Rust. I want to use Java. I want to use Python, and I want to use all the new things coming out, right? Go or whatever, right? And at multi-VM scale. So Python, for example, you can do pandas. Pandas is like what, 10 years old now, right? But it's single VM. You work for a few gigabytes of data. You can't do it for terabytes of data. It's not going to work. So again, yes. Last question I have is, so you might have other companies saying, oh, we can do all of it. We can do price performance, we can do SQL, we can do Python, we can do whatever you want. What if they're lying? Or what if they not lying? What if they are unable to keep up down the line? Right? Do you have an option? So nobody wants, do you want lock-in or do you not want lock-in? The answer is you don't want lock-in. So how easy to switch out? And so if you think of these 7 questions, you'll pretty much see very quickly that Lakehouse is the only architecture which basically answers all 7 questions with a yes, the resounding yes. Any other data warehouse-centric architecture will require compromises to be made. And I've tried to do some labeling on how egregious the compromises are. For example, native support, Snowflake's going to say, oh yeah, we can do ML, we can do something. It's a bolt-on, right? Can Snowflake do streaming? Yeah, they can do it. It's a bolt-on, Snowpipe, for example, and some other products. Performance, we are by far the fastest. Independently verified, PTCDS, okay? Snowflake will say, oh, we're not in the business, we want to do customer value. It's a cop-out. If they could be as fast, there would be a benchmark out there saying we are faster. We are 3x faster than Snowflake on the benchmark raw performance, and 12x faster on price performance, 12x cheaper than Snowflake on a similar workload. There are different workload sizes and 99 queries. Go on.
So just so I understand, comparing Databricks with Snowflake, would you say Snowflake is good for business intelligence because you're doing queries trying to see what has already happened, and you are looking more at predictive analytics.
We can do everything. That's the point. So, 2 years ago, the Databricks and Snowflake were amazing partners. Why? Because Snowflake did all of the BI stuff and analytics stuff. And we did all of the data, AIML work. What's interestingly happened is Snowflake has come into our territory with AIML support, and we have gone into their territory with SQL warehousing support. In the process, we broke the benchmark. We broke a new record, right? So if you ask me 2 years ago, we'll say, yeah, do your BI on that. If you ask me now, I say do it all on Lakehouse. You don't need Snowflake. Now, your company may have Snowflake already in there. There's political capital invested. There's already a setup. Money has been sunk in. Sure, keep it. I'm not going to say rip the whole thing out. It's not prudent. But if you wanted to, rationalize your portfolio and just go all in on one tool, go with Lakehouse. Okay? And Databricks is a part of that, to be fair. You can bring other things. We are an open system. To that point, my last one is the most important thing. If you don't, you can go in with Lakehouse with confidence. If you don't like it, you can opt out. Because guess what? Our data sits in S3. It's in Delta Lake format. It's an open format. Okay? You can always access it from anything else. You can use EMR, point to it, and run your workloads. If you're in Azure, point Synapse to it, run your workloads, right? No pressure. Can you do that in Snowflake? Can you do it in any proprietary data warehouse where the data is locked away? Can't. Right? Unfortunately, Snowflake is particularly egregious because the data is locked away in a separate tenant. It's not even in your house, it's your data, but it's locked in somebody else's house, in their house. And if you want to move things over, you've got to pay it's not going to be cheap. So that's why, I hope this helps connect dots, right? While they all say they're Lakehouse, they're not the same, right? So to my next point, right? You will see, like I said, the industry is copying us. Lakehouse is 2 years old as a concept. We coined it in 20, we coined it. 19 was when Delta Lake was announced. It took us a year. We launched Lakehouse. Industry has taken notice. And for example, you see Synapse now does Lakehouse. Okay? Synapse actually is an interesting story. I'll get to it later. Microsoft has been talking Lakehouse for 2 years now. Google talks Lakehouse. AWS talks Lakehouse. And of course, this is Oracle Cloud talks Lakehouse. Cloud Data talks Lakehouse. Revenue talks Lakehouse. Snowflake talks Lakehouse. They all talk about Lakehouse. Why? Because it is people asking for it. It's a game changer. But how do these Lakehouses stack up is my next question. And I can say this, that there's only one company which is Gartner, on the Gartner visionary list on 2 different quadrants. So Databricks is right here in the cloud database system. So within a year of our coming into the data warehousing market with Photon and Delta Lake support, we were right up there. Kind of unprecedented. This is our home base, which is our data science and machine learning. That's what we do very well. And Databricks where's Databricks? I think this is Databricks. I can't read anymore.
Yeah, that's a good sign.
Yeah. So, that I'm not surprised. This was a big deal, if you ask me, right? There was a benchmark we did with a third party, which basically said that if you take 10 terabytes of data sitting in an external table in a lake house, okay, it's sitting in S3. I forget where it was. I think it's S3. And you were to pull it in and do some work on it, and run those 99 queries, which is standardized queries. It's a standard data set, standard schema. I think it's about 40 tables, and 99 fixed queries. Okay? Take that data, read it in Databricks, see how long it takes, see how long it takes, see how much it costs. $76 total cost. Same data set. It's Parquet on the S3. Do it in Snowflake. Hit it, pull it in, run the queries. You will see it's going to be much more, right? The query costs maybe, I mean, even that's not close, to be honest. But the hidden costs are the draw, the auto, the stats collection rates and the optimization. That's everything takes compute, right? The fact is, data warehouses are, they don't, I mean, it takes years and years of being data lake native to get there, and we are there. Okay. Now, last one is this is something they never talk about. Okay, in the real world. And I tell this to all my parents. All my partners. Parents too, by the way. Because they ask me, hey, what is this thing? What do you do all day long? You know, I'm talking on the phone. So here's the situation, right? Let's say you're a client, you have data in both places. You have a data lake, and let's say you have a data warehouse also in your architecture. Now the question is, you want to do some analytics on it, you want to do some workloads on it. How do you do it? And let's say this is Snowflake, okay, for a matter of. So if you're in Snowflake, you'll say, sure, I can do an external table. I can read stuff from the lake. What do we want? Delta, Iceberg, Hoodie. There are so many formats, right? Parquet, Avro. They can do it. Sure, external table. Create external table, put the schema, put the path. Go. You pull it in, right? What do you do then? You transform it. Okay, transform done. Snowflake is good at that. No problem, right? We are both good at that. Then, okay, now you transformed it, now what? Going to write it back somewhere, no? To the lake. Try doing that in Snowflake. Can do it. It's read-only. Okay? So external tables are read-only. It's meant to be a pull. So now what do? You have all this data, terabytes of data potentially, you've transformed it, you've got to write it somewhere. Of course, you write it back to the data warehouse. That's the only option you have if you have Snowflake. Right? Think about it. Is this the Lakehouse? It's not a Lakehouse.
So I think, can you do data replication? So if you have these external sources, so you cannot move those data.
You can move it. That's not Lakehouse either. Why do you make copies of data in Lake? Lakehouse says one copy, that's it. One copy on the lake. No proprietary data sets, no proprietary copies. Right? So you probably would never have heard this before. I'm sticking my neck out here. I'm saying a read-only external table. Whoever the company is, it could be Snowflake, I know is read-only. But if anybody comes, say Oracle comes and says, hey, they're making your page, we have external table. Ask them, is it read-only? If it's read-only, it's a trap. Okay?
I think, so I just had one question that if you cannot, write on, right? So will the cost will go up? If you leave your data in the data warehouse compared to Lakehouse.
So the promises they'll always make is, we are cheaper than Databricks, we're cheaper than Lakehouse. Okay? This comes back to my point earlier. It might be cheaper in the beginning. Okay? But the intent is to lock you in. That's what I find is a little, concerning. Right? Because once we all know how Oracle works, but once you begin to use the database and the sprawl happens, and then every year they'll come to you and they'll do an audit. Okay, let's see how many databases you're using, Oracle. And then see, okay, what's the business criticality? And then they will put a number, take it or leave it. And they will negotiate hard. Why? Because you're locked in. And every business is it's a shakedown every year. You don't want to be in that place, right? So, this is for me, this is the mental test, right? If you see such a trap of being late for you, don't fall in it, okay? Because what's going to happen is it start off innocuous and say, right, you can build some queries from your lake. Very soon, when developers will come in, because not everybody sees the big picture. That's my mission to do that. Hopefully, it will change. But they will go, in 2 years, you'll have 100 pipelines, 1,000 pipelines, all reading and all writing to to data warehouse, Snowflake. And that's a one-way valve. Data is constantly coming in. This is 100% or 90%, 10%. In 2 years, it will become like 100% or it's like 50%, 50%. And then over time, the gravity is going to shift more and more and more. And somebody will say, why do we even have that data lake? Let's put everything here. It's easy,
So I'm just thinking about the previous slide that you had on the cost.
Yeah.
Comparing Snowflake. Was the cost for Snowflake very high because of this? Or was it because of the compute itself was very high?
So it's expensive on every side, basically. So this is the compute side. This is the 99 queries.
So that was $52 for Snow and 21 for you.
So yeah, that's correct. Okay. So basically, that's the raw query cost, the raw compute cost. There is effort required to bring it in and prep it for a query. That's the other pieces here.
So the cost that you just talked about, which is writing the results back in a data warehouse, you have not included here.
This is no. PPCDS is a pure analytics load.
Got it. So if
it is read, query, and then put the results on a BI thing. How long does it take? That's all.
So would I be, if I extrapolate and say the cost of ownership, therefore, should also include the other costs?
True.
This is going to burden a lot more.
Yeah. They will potentially argue, or data warehouse will argue that it doesn't. They will give it free. They will say, oh, you want to do ingress? It's free. It's the most common trick, right? Ingress is always free. Egress is going to cost you, right? So that's my that's my the meter I use to decide what's a true lakehouse, what's a fake house, right? I'll close my thing with this point, which is, like I said, Databricks, we are an open platform because we truly believe in multi-cloud and open. You won't see any of those shenanigans here. Your data always sits on the lake. It's in a completely open format, right? 100% open source, that lake. You can hit it from any system out there. It could be a Spark-based system, it could be a non-Spark-based system. Okay? It's a data format. Multi-language support, you can do whatever you want. If you don't like it tomorrow, convert all of your data into a different format. What if some new innovation happens? And we can't stop you. Nobody can stop you. Okay? So with that, I don't know, how am I doing in time?
I think perfect, yes. Yeah. So I think we can.
Sorry, I speak fast, but I hope this was good.
This was good, yeah.
Okay. So I gave you a glimpse of what Lakehouse is, what's out there. Hopefully connect some dots. Let's talk about how Databricks as a product is the best platform for you to implement Lakehouse. Okay. So I talked about how Databricks is one platform. It can do multiple personas. Because I have 20 minutes. I'm watching my clock here. I'll be honest. I cannot do the platform is so big. I could take hours and hours and hours. Right. So I will try to give you a very quick speed run of what the platform can do, and then we'll catch the rest of the questions, okay? And begin to follow-ups based on what your requirement is. So this is what Databricks, the UI looks like. Any developer who any person who wants to work in Databricks, be it a machine learning data scientist, a SQL person, or a Spark person, will see something like this. This is a notebook UI, heavily inspired by something called Jupyter, which I'm sure people know, right? So again, the notebooks thing was like what, 7-8 years old. The whole notebook wave. I mean, I cut my teeth on Java, IDEs in Java, right? And then suddenly somebody said, hey, let's do notebooks. I'm like, why? You don't have any support. Like, there's no unit testing, there's no. I mean, I didn't get it, to be honest, in the beginning. But then I realized that you can do multiple languages in notebooks. You can do a bit of SQL, you can do a bit of Python, you can do a bit of R. You can interleave them, and that's powerful, right? And it was a great tool for data scientists to do exploratory data analysis. You run a SQL query, make some views on it, do some joins with SQL, make a temporary view, and then the next one, bust out Python, and now you're doing a scikit-learn model, right? So we can do all of that here. So, and we can do more. So this is like a notebook plus, okay? So, so first thing first, in Databricks, we have these 3 workbenches, which is a persona-driven workbench. This one is the data science engineering, which if you came to us 4 years ago, we only had 1 workbench, data science and the notebook UI. That's it. What we've done, as we support more personas, we have brought in a separate workbench for machine learning, more tuned for data science, and most recently we brought in a 3rd workbench for data SQL analysis, which surprise you'll see is I won't spoil it. I'll reserve my comments there. So this is the classic notebook where people. This I think that there's a default language, in which case it's Python. People write they write the commands in cell. So if you don't see anything here, this is by default Python. Okay. There's markdown support, so you can have nice self-documenting notebooks with pictures and attractive, nicely formatted text. You can do things like so we call it a magic command. So you can start connecting notebooks if you want. You can bring in modules. You can run shell commands. Right. In this particular case, this person is running a different notebook. So you can now modularize your work. So this is the classic. So this is the I'll go to a different. Yeah. So this is going to a second notebook. Now this notebook is actually a machine learning example where you're taking data, you're doing some work in it, and you're creating a feature. Right. So everything pretty much here is Python. This is not SQL here. I'll take a different notebook. This one, for example, is a more data engineering specific notebook where, once again, you're starting off in Python. You're switching to SQL, right? Here the default language is SQL. So if you want to do Python, you put a % Python in your as a first line in your cell. Right? So here I'm creating some SQL tables, I'm switching to Python and doing some more parquet reading, right? Then you see I'm going back and forth here between Python and Scala. Now, how do I run this? I wrote this notebook, I wrote this code. How do I run this? To run this, what you do is you go and spin up a compute cluster in Databricks, right? So I would say create compute, and I can choose where I want to run this. Okay. Now, if the typical question I get is, okay, how much is this costing me? So the first thing, when you're working in notebooks, it costs you 0. The notebook UI doesn't cost you a cent. You only pay when you run compute. So you want to execute the notebook, you want to spin up a cluster. When the cluster spins up, the meter starts. Okay? And the way you work is, you want to split up a cluster, you say, okay, how big is my workload? If it's say a terabyte size data set, I'll basically go and pick, say, a particular VM type. Let's say I want to pick an i3 for its large. I could do auto scaling, I could do non-auto scaling, right? So I'll say I want 8 workers of 16 cores each with 1 driver of 16 cores each. And that's one way to start. If you think my load fluctuates over the day, I could create a cluster, share it with multiple people. And people, when they go for lunch, why am I burning 8 cores? Auto scale. It'll bring it down. Right? So number of cost features for folks who are looking at the bills, right? So you create a cluster like this. Once a cluster is created, what I will do is I will connect that particular notebook to any cluster. In this case, I have a shared cluster across all my company, all my fellow SAs, and I will run. And I will run. If I say run all, it will run all the cells in the notebook. Okay? I ran this, everything looks good. I can schedule my particular job. Okay, if I do schedule, it'll say, okay, when do you want to schedule it? I'll say, okay, I want to do it, every day at a certain time, right? So a lot of features over there that you can schedule. And once you schedule, it becomes a job. Okay. So now you basically create notebooks, schedule it, and you're automating your work. You move on to the next topic, right? So this is a simple example of a data engineering cluster, data engineering workspace. So typically, you would take a data set. Let's say, how do you use it? How does an engineer use it? Some system out there is dumping JSONs or TXTs or some format, right? Structured, unstructured, could be audio files, video files, some binary format, it's dumping it on a lake somewhere. First thing, data engineer comes in, I go to a notebook like this, I'll say, point to S3, read the data set, and then write some logic to process it. Use whatever language you want, Python, Java, Scala, R. You have libraries in, some read library in Python, bring it in, no problem, okay? Do it. You did that, you picked up the CSV, text, JSON, whatever, processed it, cleaned it up. Now what? You're going to save it somewhere, no? Save it back to the Lakehouse, back to S3. But not as JSON, CSV, TXT. That's an awful format. It's uncompressed, there's no schema definition, right? You save it as Delta Lake, which is the default format now. Saves Delta Lake, highly compressed, schema information, lots of ACID, and it's consistent and atomic and all that good stuff. Done. Your job is done. Next, machine learning guy wants to come in, wants to process it. What do? They go here into the machine learning workspace. You could do it too, but it might be somebody else. And here's the cool part, AutoML. So my first course passion is typically AutoML. So a citizen data scientist comes in, there is a data set already ready, it's processed, ready for you. What do? I will say, okay, start AutoML. All right? First thing, so what does AutoML do? Think about it. In AutoML, it's basically you're making an experiment and you're telling the system, here is your data set, and I want you to train yourself on this data set and predict a particular column. Okay? Now, a typical data scientist, they do a few steps, right? They take the data set, they do a split on it, right? A training and a test data set. Then they will run a few models, and they look for things like how well fitted is this particular model to my test this thing. That's a lot of work, right? Because you could be running like 5, 10, 15, 20 models, and they're all giving different metrics in the end. Your accuracy metrics or how do you, that's boilerplate. 5, 6 years ago, it would take a PhD all day long to run. That's all they did, model all day long. AutoML removes all that drudgery completely. You simply go with AutoML, you pick a cluster you want. So in this case, I'm going to pick, say, I'm picking a cluster. I'm going to pick a problem type. Let's say it's a classification problem. Pick your input training data set. Okay, I'm just going to pick something for now. Okay, and then you got to basically decide what you want to predict. So typically, you want to predict something like, this. The point is, you load the data set, pick what you want to predict, hit a button, and it will basically say, okay, I'm going to pick something. So this might not be the right one, but give it a name for the experiment. Right? I give it a name, and when I say start AutoML, what it's going to do is it's going to take all the boilerplate that a developer would have done 2 years ago. It will do it for you. It will take the data set. It will do the test train split. It will do the conversions of the real data, the human readable data into machine data science friendly features. Run a bunch of models, collect all the stats on it, and give you a nice report at the end of 1-2 hours. Right? And then all you got to do is walk in, look at the results, pick the best model based on what you think is the best model, and it's going to give you the code for it. We call it a glass box AutoML. It's going to give you the code for all the Python code, what went into processing the data set and giving you the model. All you got to do is take the model, take the code and stick it in your repo. Okay?
So I just had one, a question. So suppose we are writing fraud, right? Machine learning model. So once I make it live, right? Do I need to have the server running, all the time, or whenever somebody makes a call to that machine learning model, only can the?
Okay, good question. So this is the model inference part. So what I talk about is the model training part. Okay. So there is work required to create the model, train the model. Then that model is basically what? It's a Python function. Okay. It's a Python function with some really convoluted code which nobody knows how it works. Whatever. You got to plug that into some system where it infers. Now you could take that model and you could, if it's a sporadic, 3 times a day somebody calls the model, put it in a cloud function. Okay? Serverless, pure serverless, put it in a cloud function, expose it as a service. Done. You're good. Right? If you think it's going to run, oops, what happened here?
It might be the screen
Yeah.
lock.
No, yeah. So the other option is, if you know it's going to run, say, 10 times an hour or 50 times, actually serverless could do that too, but let's say it is running on a smallish data set, you're processing a gigabyte of data in a day in one batch, right? Do you need Databricks for it? No, you don't. Take the model, stick it in a Python program, run it once a day. Single VM work. Okay? No problem. We're not forcing you. But if now you say, look, I need to process a gigabyte of data or a terabyte of data every day. Okay? And that model has to be applied to a terabyte of data, millions of rows every day. Then yeah, sure. You can take the model, put it in a Databricks notebook or in a Matillion notebook and run it on a massive cluster in Databricks, right? You could, if it's streaming, you could put it as part of a stream. And you could run the same thing as part of a stream. You can even take your Python model, make it into a UDF, and run it within SQL. Think about that. Kind of blows your mind a little bit, okay? So I could expose my Python model, fully trained model, as a UDF, a SQL UDF, make it available to my data analysts. And now, as part of pure SQL scripts, they are running Python code in the back without them knowing. You can do all of those things with the Lakehouse, with Databricks on Lakehouse. Okay? So this to me is like the one thing that I always tell people to be aware of. Now, if you have hundreds of data scientists making thousands of models, how do you keep track of all the models? Right? And every model has different characteristics. We have a thing called ML flow, which again Databricks, Matej Zaharia, the guy who invented Spark, right? Super genius, he saw this problem and he invented a thing called ML flow, which is a tracking system. So every time you train a model, it makes a record of what did you do, what inputs you gave, what outputs came out, what is the binary, stores it somewhere, right? And so we have a model repository, a model registry, we have a feature registry. I won't go into that right now, but everything is tracked and everything is built in. Zero work required for you. On Databricks, all those things are right here. So if I go into this is my model store. These are all the models that have been created. Okay, and it's what's in production, what's the version, what's in staging, right? If you click on a model, for example, it will tell you it's got a bunch of information on what inputs go into it, what outputs come out. You have all the information right there. All the collaboration is taken care of for you. Okay, and like I said, you can deploy this if you want to deploy it. It's a one-click deploy in Databricks. You want to put it somewhere else. It's a few lines of code. Push it where you want. Nobody's forcing you. Okay, I got 5 more minutes. Finally, the newest part of what we do, which is the SQL part. Now, the UX here should not be a surprise. Why? It is absolutely intended to copy what's already out there. Okay, you catch any SQL person, they have an image of what a SQL workbench should look like. Left is my catalog schema, catalog schema tables, right? Then I have let me show you what I'm talking about. So that's my schema browser. This is my query window where I can write my query with IntelliSense, autocomplete, and formatting support. And then this is my result query, my result box, right? We're not reinventing the wheel. Okay, go with if it ain't broke, don't fix it. So we did that. Now, there's some innovations here too, by the way. Again, hidden. You want to run a query, how do you run it? You need a compute backend, right? So you attach it to a particular, some compute backend. We call it a SQL warehouse. Here, again, no surprise, right? We used to call it endpoints and whatnot. Like now, let's go with the industry terminology. SQL warehouse, right? You want to create a SQL warehouse? Go here. You create SQL warehouse. It's basically the same. It's a similar screen to create cluster, but it's simpler. Guess what? Because data guys don't give me choices. You know what? Keep it simple, right? So for query friendly, for query type activity, we know exactly what VM type works. We've done all that extra configuration work for you to be very simple. We even give you things like multi-cluster support, right? So you have you can, as your workload increases, you can spin up multiple what do you call these things? Okay, we call it clusters now. So we can spin up multiple clusters in the back. It's one endpoint, it's one warehouse, but it's scaling up and down depending on load. Which means I make one endpoint, one SQL warehouse, I give the URL to everybody here in the whole company, 5,000 people, cool. And I set some scaling limits, and when 9 a.m. on a Monday morning, when everybody comes in, you'll see it max out. But by lunchtime, when the demand slows, you'll see cluster shutting down, and now you come back into a optimal usage. Okay, so we do that. Again, this is an homage to Snowflake. Snowflake, in the beginning, we had a very different worldview. Snowflake said, you know what? We will create the clusters, the compute in our tenant. You want to run your query? The clusters on my side. You just put your data is on my side, the clusters on my side. Databricks initially said, no. Everything is on your side. The cluster is on your side, Databricks, the data is on your side. Fundamental philosophical difference. Guess what? We initially thought that nobody, like who in their mind will want to put their data in some, outside. Like if you ask any firm, any financial company, hey, are you okay with giving your data to me? I'll put it in my house. I'll take care of it. I promise. Right? Will you do it? Well, we thought nobody will do it. Guess what? Everybody's doing it. Right? I don't know how they pulled it off. Respect. Right? There are advantages to it. Snowflake can do a lot of cool things if everything's on their side.
They can share.
They can share and they can optimize their compute and they can give you like instant. You want to run a query, instant or 1 minute your query responds back. We could not do it. If the clusters are in your tenant, it takes 10 minutes for the VM to start up. We have no choice. It takes 10 minutes for Azure to go find VM so the cluster to start.
So you're talking about the replication, right? So you can replicate the data in the Lakehouse, and then you can run the queries on top of that.
To run a query, you need a cluster.
Mm-hmm.
You need a VM running some software which we provide, a runtime that we provide. So in the old school, the old system, you're running a query, you say, I want to start a cluster to run queries on. The cluster, when you say run start cluster, it will go find VMs in your tenant. Then it will spin it up, it will then, it's got to configure it. That would take 5 to 10 minutes. And then the data can be anywhere, replication or not. But that was a problem. With serverless, the cluster runs on our side, right? So data still sits in your tenant, no replication. Data is not replicated, but the compute is on our side, and it's all very fast because these are all like co-located, compute and data. It's all in the same data centers, but it's very fast. So the platform is evolving based on the requirements we see in the world from our customers. We have done a lot of interesting things. Right.
So I think if there are like millions of records, right, in external data sources, and I think let's just take the prescriptive analytics side, right? I mean, where we just need visualization reports. So is it like very slow if there are like a lot of data? And I think, if you are getting these VMs started, getting this data.
It used to be. That's the problem, right? So if you historically it was a challenge because every time a cluster is starting up, it's a 5-minute wait.
Mm-hmm.
With serverless, we have pretty much killed that problem. Because what we do is we are on the compute's on our side, so we keep VMs running. We are paying for it. Okay? You are not paying for it. We are paying for it out of our pocket. So we always keep VMs running, idling and warm. The minute your request comes in, we'll pick a VM or two, whatever your cluster requirement is, quickly configure it and put it to service for your query. And it's only for your query.
And the data is on user side.
Yeah, so this VM will basically go and, because it's on our side, right? You have a query, your data is in your tenant. What we do is, cluster starts up, dedicated to you. It's going to pull data from your tenant, do the compute, and write it back to your tenant if you need to, and then done.
So would you say that the biggest chunk of time would be transport of data?
No. So again, 5 years ago, I thought, how will it work, man? we thought there'll be these big bottlenecks, no, with network issues. No, they're not a problem. And they're not a problem simply because typically all of these things run within the same data centers. And they have massive high bandwidth, network connections between all the VMs and all the racks within the space. There's a lot of engineering that goes into making it very, very fast, that you won't even notice it.
So your computer center clients, if they have Northwest, is going to be in the same center.
No, it's in the cloud. It's in the Azure data center.
Right. And the cloud it's co-located in the same cloud.
Yes. So it'll be, we make sure that we put a VM pool in. So for example, let's say you're in the US Central region, okay? So we know what data centers are in the US Central region. We'll make sure that we have idling VMs in the US in the same data centers. So when you put a request for, hey, give me a serverless SQL endpoint, boom, it's there, ready, right? So that's the engineering. It takes a lot of monitoring and tuning because we pay the bills, so of course we'll tune it, right? You don't need to worry about it. Key point, last point is, if you look at the endpoints here, if you look here, each endpoint, actually this is not a running. Let's pick this one. So this is a shared endpoint. Every endpoint has a URL, which means I could give that URL, as I said earlier, to everybody in the company. They all have their own credentials. They can either use a SQL client and they can hit this. They can use a Power BI, hit this, a Tableau and hit this. It's JDBC, right? So it behaves just like any data warehouse, no difference, right? The back end is completely different, but the front end is the same. It's like going from a Yugo to a Tesla, right? The controls don't change, the back end is different, right? So with that, I'm going to pause because I think I'm 5 minutes over. Apologies. All right. I'm happy to take questions after the Matillion diagram.
Absolutely.
But,
Do you want a few minutes break for folks?
Yeah, absolutely. I think that's like, I could take like a 5 minutes, break. We have chips, cookies, drinks, yes, please. And then I think we will then continue with this Matillion workshop.
Thank you for listening.
Yes, thank you. It was a good session. My name is Fakruddin. Manager here at Alsaza. One quick question. So we support a lot of financial institutions, right? And one of the pointers that
But just a quick raise of hands. Who here is familiar with Matillion, has started Matillion, has used it, very shorthand. So that's fine, because actually we're on the up and coming, we're swinging high, and as we mentioned, we have backings from Databricks recently, and just to let you guys know, we are obviously cloud platform, cloud agnostic as well, so we do also work with our former counterparts, Snowflake, and any of the others. But here we're going to talk about how do we work with the Lakehouse architecture. How does Matillion fit into everything that Sue kind of beautifully explained to you guys with the benefits of the Lakehouse architecture? So that's what I'll do. Rob, my counterpart, is not here due to COVID, so it's just me today. But here's my information here. Me. I'm based out of Chicago. I'm in Wilmot, not too far away from here. So, but what do I do at Matillion? I'm a senior sales engineer at the enterprise level. So my role is similar to what this team does, which is provide solutions and how can Matillion help you solve your problems and help you accelerate the adoption of the Lakehouse. And what is Matillion, right? So we're going to quickly run through these slides. I want to make sure you guys do get hands on keyboard. So if at any given moment I'm talking too fast or you have questions, please interrupt me. I'm happy to answer your questions. So what is Matillion? So Matillion is a low-code, no-code tool to help you accelerate the adoption of the Lakehouse. Anyone here work in the ETL space? Informatica, Talent, Data Stage, PL/SQL, these are familiar to you guys. How's that? Has anyone here made a journey to the cloud with these platforms? Okay, so I think if you get to that point, whether that's with Databricks or any other cloud platform, you'll see that there's a big gap there as far as their ability to play and scale to the speed of what Stu talked about, right? Like the market, the tech is flying at 1 million miles per hour, and these legacy ETL systems were built for a time before the time that we're in. So our founding, people of Matillion, they recognize that. They actually started as a talent implementation shop. They worked in talent and said, you know what, Redshift is awesome. It was the first big cloud-based platform, but it just doesn't do what it needs to do. Talent doesn't do that. What Redshift is able to do, because what ends up happening is, everything with these legacy ETL systems has a compute engine of its own. So you end up moving the data from, let's say you're working with Oracle SQL Server and you want to migrate it to Databricks and to the data lake, Delta Lake format. What these platforms will do is force you to read that source, push it into their compute engine, massage the data, and then throw the final values into the Delta Lake. Well, then you got to ask yourself, well, what's the purpose of me owning a cloud-based platform? Because, as Suba mentioned, the goal is to scale, to run at the speed of technology, and that's what it's designed to do. What it's basically like buying a Ferrari and parking in a church parking lot and driving at 5 miles per hour. Because if I bought a Ferrari, I want to be on the Autobahn, ripping through 8 gears, going 200 miles per hour, trying to get killed, right? Like that's the point of a Ferrari. But it's not very good if all the work is being done on a proprietary engine that's doing it for you and delivering you that final value. So how does Matillion differ, right? And I'll go through the architecture slide to show you that. But basically, what we have built is a platform that not only allows you to help move data from 100 different sources. We have all these connectors that are free to use. We don't lock you in. It's like, you want to use SQL Server and Oracle? Well, that's going to cost you extra money. All of our connectors are free to use, and we actually enable you to build your own connectors. So if you're using any sort of REST API endpoint, and we don't have a connector built for it, we have a wizard that walks you through designing the actual response from that API with authentication, and you can save that profile to be reused in pipelines going forward. But in general, Matillion is basically a low-code, no-code UI tool to help you build pipelines. You're able to ingest data through, and then afterwards invoke pushdown SQL, which in this case, once we're running Databricks, what we'll do is build transformation jobs that you drag and drop different functions like joins, aggregations, filters, you name it. And all that's going to do is generate Spark SQL on the background that's being pushed onto the native cluster that's running in your Databricks environment. So the big difference is here, the data never moves out of your environment, right? The compute that's being used by Matillion to ultimately massage that data is the same cluster that you just spun up to use the MLOps job, or the same cluster that your data engineer used to write Scala or R, what have you. You share the same cluster or the same subscription at least. You might devote maybe a SQL warehouse for these functions or something, but nonetheless, it's all staying within your four walls. So if you're dealing with HIPAA data, you're dealing with sensitive data, you don't have to entrust another entity, as Suba said, like put in their house and trust that they'll maintain that for you, because we run natively within your platform. And these are kind of the key things here, right? There's a lot of initiatives, there's a lot of things that people look for in the market today. Big one being data ops. Are you guys familiar with data ops? It's using a SQL as code, for example, and being able to efficiently manage SQL. I think we've all been in the place before where we wrote like that really awesome SQL script, 2,000 lines long, and then you've left the company, you're like, good luck, because documentation was poor, I was building it in a pinch, and I'm done with it. So data ops is the mission of that, right? You use things like Git and CI/CD to deploy code and be more routine, strategic, and really scripted to be less user-proof, less error-proof going forward. So these are all the things, obviously, we mentioned with Databricks Venture. So Databricks as an entity, as a company, looked at Matillion and saw the value that we bring to their environment, to their users, and have essentially invested in us as an entity, as a backer of ours. So this is also true of other vendors, but we'll keep it to Databricks today. So how do we win together, right? As I mentioned, and we saw with the UI and all the features and functionalities that's so wide with Databricks, there seems to be a lot of times a little bit of anxiety to adopt that native hardcore scripting, do it yourself, do whatever you want, the world's yours. And we kind of help bridge that gap, right? I mean, I can't write Scala, I can't write Spark, I can't write a lot of things. I can write SQL, but I can't write a lot of new cutting edge, data engineering types of things. But that's fine, right? We want to have a platform to make your team and yourself more productive. And actually, we've coined ourselves as a data productivity cloud in our last event. So our goal is to make your data and yourselves and your team to be as productive with your data as possible. And we're doing everything we can to make sure that you can not only walk and run, but sprint with your adoption of a platform such as Databricks. So how does Matillion fit in, and what does it do, and kind of what does it, where does this basically fit into Databricks, right? The Databricks essentially do everything. And where do we fit in? It's basically we help you to transform the data through the 3 tiers that Databricks coined, which is like bronze, silver, gold. Are you guys familiar with that terminology?
No.
So the bronze, silver, gold paradigm, and correct me if I'm wrong if I get this wrong, but it's basically these stages of which your data goes through in its life cycle, right? So when you ingest that data, say we're dealing with an API, maybe I'm a healthcare company and I have a government API that I hit to get some sort of metrics. When I stage that data from that API call into my raw or bronze layer, that's kind of what the bronze layer is, right? It's that raw data as it was received, and that's the premise of the Lakehouse, right? It's one copy of data. It's not, I have 10 different versions or what have you, right? When I deliver that data to the bronze layer, that's its raw format. Now, of course, it might not be ready, and most times data, when it arrives in its raw state, is not ready. You need to do standardizations, you need to join, you need to do all the other things. So that's the journey that it goes through in its life cycle, right? You land the data, bronze. We apply company-wise cleansing, masking social security numbers, deleting of like faces, what have you. That lands in the silver layer at that point, right? And then eventually the gold layer is your presentation layer that you might use for Tableau or Power BI, what have you. But how do you move that data between bronze, silver, gold? All this is just basically saying the stage that it's in. You could write notebooks. You could write notebooks, put into data frames, use your skilled data engineering team, and do that. And you achieve that goal without Matillion. But the problem is also a skill gap, right? I don't know if anyone here manages teams or has to find resources, but the data engineering market is probably one of the hottest markets to find talent because it's so scarce. A talented data engineer can really do magic, but to find one and compensate for one comes with extraneous costs. And really, it's not just so much that you don't want to hire them, but they just don't exist. Most of them are happy, and companies do what they can to keep the good ones around because they know their value. That's where Matillion fits in, right? As I mentioned, we're here to be the data productivity cloud for you. We want you to help scale your teams. We want you to have the folks that have never written a line of SQL to be able to produce very sophisticated pipelines, leveraging the powers of Databricks without having to know the nuances of building a sophisticated workbook that has all the steps that it needs to do and all that stuff. But it also allows those people that are capable of doing that to incorporate themselves into the same platform. Because as you'll see when you go through the demo, we do have the ability to orchestrate multiple different calls, right? We can call data to be ingested in as part of a pipeline. We can call notebooks that are native to Databricks to be part of a pipeline. We can grab some error handling around that, and then of course invoke transformation to be executed in the Lakehouse using Spark SQL. But you'll notice there's a lot of times to be in basic and advanced mode. And as you can imagine, the basic mode is going to be the one that kind of walks you through. It's your hand holder, right? Where it says, you don't know how to write a line of SQL. You might be fresh out of college and you hired a VA or something that you need to kind of help move along. And that basic mode in the components will tell you to choose the table, choose the column, where you want to go. The advanced mode, open SQL script. It's the world's your oyster. But you can still leverage the components natively within the platform to achieve the same goal. But really, we don't want to be a hindrance to your team. I know, I come from a deep background. I come from 13 years in ETL. I've written thousands of lines of PL SQL, you name it, work on Informatica, warehouse builder, plethora of tools. I know some folks look down upon GUI tools. They enjoy writing scripting. Fine. We're all open to that Matillion. Whether it's through native components that allow you to write that hand SQL there, or using notebooks and incorporating that. But the common thing here is we want you to encapsulate everything into one environment. And because we use native compute from Databricks, you're not also involving another platform to tack onto this investment in Databricks. Everything's happening in one place. It's just another UI for you to help adopt and move towards that cloud as a cohesive group without having disparate groups saying, well, no, we use Power BI, we don't like anything data engineering, we're going to stick to our own. This will allow you to kind of encapsulate the whole team with that. And this is where we fit in, right? And you'll see as we walk through the demo what it does, but I want to kind of cover how we also deploy it. It's a little bit different than, as I mentioned, those our main competitors, right? So this is true for AWS, and you'll see this as it looks exactly the same. But in our current model, to spin up a version of Matillion, what you'll actually do is you actually spin up your own virtual machine within your own subscription, whether it's Azure or AWS, and you're gonna have total ownership of that virtual machine. So whoever your cloud admins are, or your DevOps team, they'll pull an AMI image or cloud permission template from us. They'll spin up a virtual machine within your subscription. It's going to self-install Matillion on it, and you'll have total ownership. So think about all those those long hours that your security team have gone through to lock down that VNet, make sure that no one has access to your VPC. It's in that same VPC, so all those security roles and restrictions apply. You have total ownership. You can spin it up and spin it down, save costs. And then all the networking that happens between that virtual machine and your sources that you're pulling from are going to use all the same secure pathways that are already applied on the VNet or VPC. So whether it's a VPN to connect to a SQL server on-prem, or some sort of subnet setting that you've implemented, it's shared on that VM, which is completely different versus a SaaS offering which says, oh yeah, give us access to that VNet. We'll make sure you open the firewalls for that SQL server. We'll authenticate. We'll pull that data out. We'll run it in our machines, and then we'll serve it to you. And trust us that we'll follow GDPR and all that fun stuff. So this is kind of falling all in line with that openness and putting you in the pilot seat and you in total control to trust that this data never leaves your four walls, right? Because what happens is when that virtual machine makes that call, right, it's going to get a response back. We connect a REST API or DBC to databases. That once that data is coming back, the virtual machine never holds that data, and the response coming back is generating flat files on the fly and staging directly in your S3 or your blob storage. And then what happens immediately afterwards is the virtual machine tells Databricks, hey, I staged some data for you. I need you to ingest them into the Delta Lake format. So all that's happening on the fly without you having to script all that together. You'll see how quick and easy it is to get data through. And if you guys want, we can walk you through a live example of how easy it is to ingest even a JSON API endpoint. So maybe something that's newer to some folks here or haven't used it, but JSON, for example, is taking the text space by storm. XML is going to the wayside, and most of your REST API delivery is going to be JSON. And I can walk you through that if that's of interest. But nonetheless, the main thing is the data stays at home. It moves once. It moves from that source database to that Delta Lake table, and from that point on, you're geared to go to do machine learning, to do any data engineering you want. It's all sharing that same Delta table that lives in your S3. Are there any questions so far?
So I think just to understand this completely, so you're saying that if you're using Talent, right, or any other ETL tool, so they will, if they are offering the SaaS offering, so the data will actually go there. You will create a pipeline. The data will actually move there. They will do the transformation, and then they will send the data back, right? Whether it goes to the data warehouse. Or
if they're doing a serverless or Talent hosted or informatica hosted servers, that's exactly what's going to happen. Rather than the data flowing directly to Delta Lake format, it's going to go to some obscure server. I'm sure obviously it's secure if you're a large company, not saying they don't know what they're doing, but still, we hear about hacks every other day, right? Mm-hmm. No company's prone to it. No company's invisible to it, right? So it's that entrustment that says if there is a breach, what could you done about it? Nothing, right? It's in their servers. You don't have access to it. So all this happens, like I said, within AWS, within a traditional subscription, without having to send that data back and forth. And the key thing is to remember this, right? When you have a SaaS offering from Talent or Informatica, they're going to charge you like compute hours to run their clusters, which you have no visibility over. Tuning is almost impossible because it's essentially a black box, right? You build it in their UI, you send it, and you just wait. And they might give you some metrics, say, I know this is what's happening, or maybe make some changes here, but ultimately you don't have visibility of what's going on. Matillion, we generate Spark SQL, open up your cluster, see what SQL we invoke. You, as a SQL expert, will be able to parse it. You get the execution plan, do some sifting. Maybe the SQL that we generate isn't maybe the best approach for what you're trying to do. Scrap that one component, throw your own SQL component that you feel is better tuned, and run that in your pipeline. So that's the leverage you have because everything, like I said, is in your subscription. you have total ownership over it. So without further ado, I think we'll just
And I
jump
think
in.
just one more question.
Yeah, sure.
In the so in one of our projects, we are actually one of the struggles we are having is the data from a data source perspective is getting data from mainframes.
Mhm.
Do you
Like
have?
DB2?
Yeah, DB2, correct.
Yeah.
So I think, do you have any better solution, because we are currently using Talent, and but I think it's as you know, is a very cumbersome process, right? We have to get the files. There is no query language, right?
Yeah, you extract a flat file and then parse the file,
Parse the
review,
file,
and
and-
stage again. Yeah. So yeah, we would connect to DB2 over JDBC, right? We did DB2 or DB2 for I, whichever driver. And actually, let's kind of just jump in and just look into that, right? So we have the ability to upload your own JDBC driver. Like we try our best based on licensing issues. Like Oracle doesn't allow us to ship our product with their Oracle driver because they want you to accept the URL and download it. So we have like out of the box most drivers for most common platforms, but there's gonna be one-off ones, like maybe a legacy mainframe that doesn't have it. You can upload your own JDBC driver because you own that virtual machine, right? You can install what you want on that. You want to install Datadog on it? Go for it. We can't stop you because ultimately you are the owner. We can obviously provide some best guidance, like well, if you install X, Y things, you share the resources at Matillion right now, you might see degradation. So within reason, you might have to obviously give and take, but ultimately, like I said, you are the entire owner of that. And as far as connecting DB2, yeah, we connect with it. We have CDC offerings for it, and I can show you kind of through the routine walkthrough of how that'll work in general. But before we dive into the actual platform, everyone here has laptops, correct?
Yes.
Yeah. So what I'll ask for you guys is quickly log in, make sure you guys can log in, and you can save this information for later. What I'll do is I'll number you guys off to make sure you guys each have your own user and stuff for you learn. So 1, 2, we're gonna participate.
I'll watch.
Yeah. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then 11 in the back. So everyone got the number? You go as well. Okay. So like I said, this is what you're going to go through today is going to be all in that documentation. I'll leave this virtual machine up for the rest of the day through the night. I unfortunately have to spin it down early tomorrow, but I will also present an alpha to you at the end. But I did want to make sure that everyone can log in. So obviously the username is going to be user 01 or user 10, what have you. So, and then the Matillion 1, 2, 3, 4 is the password.
11,
So this is not the one,
11 was behind you, I think, right here, 10.
is it HTTPS something?
HTTPS, yeah, you should just type in 34251 85 246. Maybe you're just 12 or 15 or forget. The one thing I'm not good at is memorizing things. You can be 13. I'm going to be a panel for you. I have 20 users set up. There's 40 in there, but 20 only will configure 25. So I think we have plenty extra here. So if you forgot your number, just choose a higher one.
Okay.
Everyone logged in for the most part. Any issues?
I'm fine.
I mean,
Everybody is logged in fine? Asif?
You might get if you're on Mac and you get a certificate error, just type in this is unsafe and keyboard it and it'll pass through. So once you log in, you'll be presented with a project selector. So just choose your project, obviously according to your name or according to your number that you have, and you'll be presented with essentially nothing on the screen, right? So what I've done for you in the workshop, I wasn't sure how much time we're going to have, is built out a partial workshop and a full workshop, and then of course a solution. So as we go through the document, the goal here is to kind of show you how can we stitch data, how we source data into the Delta format into the data lake, and then massage the data natively when it lives there, right? So if you're looking at this workshop document, I honestly, unless you're really interested in the ingestion portion, the power of Databricks can be from exercise 3 and 4 onwards, because when we ingest data, the virtual machine will do all that work. It's not going to use the compute power of Databricks because we're organizing the flow of data into Databricks environment, and once it's in Databricks, we can transform it using the cluster. So that'll be exercise 3 and 4, and I'm not going to bore you to death by reading this through, but the concept of the exercise is we're going to load various data sets into Delta Lake format, into Databricks, right? So if we look at the actual solution, you'll notice that before any jobs kick off, zoom in so it's a little bit easier to see. You're going to see that we have multiple components on the screen, and they're kind of stitched together. And without being a Matillion expert, I would argue that most people here can kind of have a basic idea of what's going on, right? So one of our key things in Matillion is we're super focused on making things easy to use, right? We've actually gone away with a lot of things that are I would say, standard in most ETL tools. Like, who here has ever had to ingest data into Snowflake or any other platform and have to predefine the table that you're loading, making sure you get the data types right, and it can be kind of confusing, right? Because what a string, well, I mean, not a string, like a unique data type to SQL Server might not exist in Snowflake, Databricks, whatever. So you have to know, of course, okay, if I convert it, what it's going to be. You don't have to do any of that in Matillion. What we actually do is we do a schema on read. So when we read that data source, and you're bringing that data over based on the configuration of the component, we're actually going to create a table for you on the fly without you having to worry about the structure of it. So no mapping definitions, no source definition, no target definition. It's purely, hey, I want to hit a database, right? So this is a database query. This is where you would hit, for example, DB2. In this case, we're going to connect to a Postgres database, and we're using the advanced mode. So we've written our own select statement, right? So if you, in this case, want to source data from a Postgres database, write the query that you want. It'll fire over GDBC command, come back to data, and it's going to do. It's actually going to create a table on the fly called airports Postgres. Notice how it's not a drop down. It's extra free text because, as I mentioned, we're going to create this airports Postgres, and I know you can't really see it because we do the scaling, but on documentation you'll see whatever name I put this like KB after. It's going to create a brand new table called Postgres KB without me having to go and create that in advance. So imagine the speed of what you can work, right? You're not slowing down to think about schema change. Gotta go fix that before my pipeline failed. Like this will be reiterative because the goal here as a true ELT platform is we want to extract and load the data in raw format as quickly as possible into your cloud data platform to allow the cloud data platform to do all the transformation with its infinite scale and power. And how can we do that? How can we extract load at the speed of light if we have to slow down and define all these things on the fly? And basically all of our components do is stage the data in its raw format, and it's basically your goal as the next step is to use that cloud data platform to move it to the different layers, right? So I've loaded this API call from the government. I need to move it to a more proper table, just cleansing, joining. You're going to do that with different transformation layer. So in the solution that you'll see here, this is kind of what your end goal should look like, right? You're going to have a Databricks query. You can sample the data to source the targets. This is also a very quality of life improvement, right? We've come from we come from a large group of data engineers, a lot of ETL developers, people that have worked in the database for a long time, and we always ask ourselves, what did we dislike a lot about our previous roles, right? What slowed us down? And for me, it was always juggling the multiple UIs, right? If I had to source data from Oracle, if I had to source data from SQL Server, work in Informatica, and then I'm loading it to wherever, right? That could be 4 UIs I'm running on my machine. And you know how it goes, you'll time out of one, so you're like, wait for that again, bounce back, and the other one timed out. The nice thing about this is also a consolidation platform. I can query the source database and sample it in real time when I'm working with Matillion. I can also do the same on Delta tables, right? So as I jump into a transformation job, this table input is reading the Delta live table, the Delta table in my Databricks environment, and I can sample that in one UI. Now, of course, I could have a notebook open and do the same thing, but when we're working, right, we want to be kind of laser focused, and this allows you to be as productive as possible. That's our goal, right? Without you having to bounce around, without you manage all these different UIs. So just the last thing I want to mention, right? Like we are always tuning our product for your deployment. So what we're looking at here is AWS deployment of Matillion for Databricks. Now, if you're running Azure, you're going to see different options, but the UI and the workflow will be all almost identical. You're going to swap out things that are obviously native features for that platform. So what I mean by that is when you're running in an AWS environment, you're going to have features to do like an SQS message, which obviously is a AWS functionality, or a CloudWatch publish, right? If I was working in Azure, I might have a queue message that I want to send. So you have a lot of things because we're running natively on these platforms. You also have the ability to kind of incorporate these native functionalities within your pipelines. We have, for example, like Python and Bash scripts that allow you to make AWS CLI commands, right? Maybe you have a job that says, hey, I pull some data from a SQL Server database, and then I need to do an AWS CLI command to fire off some Mongo trigger before I run something because it does some sort of check or what have you, right? All that's being done within the same orchestration, within the same UI. So don't just look at it and think it's just a pure ETL tool or a data migration tool. It's more than that, right? It's a complete end-to-end platform, but it also harnesses the power of the investments that you've made, right? If you've chosen to run your organization on AWS, if you've chosen to enable Databricks as your cloud data platform, we want you to get the most out of that via Matillion. So there's a lot of built-in functionality that we don't have enough time to go through every single offering that we have. So really, it's just I will spend the last kind of few minutes because we're at time here to just walk you through this simple scenario that you're going to go through to leave you in maybe a more grounded place to do the exercise on your own. That's all right.
Perfect.
Good. So what you'll do is when you kick off and you log in, I would encourage you guys, for time purposes, to start the partial workshop exercise. You'll notice there's a green file called Flight Plan Bronze Partial, and it's partial because I've done the first two steps for you, right? And you'll see this some things going on. And you're free to look at what it's doing, right? If this is just how do we move data from S3 into a table? You have the copy command here. You can always look at what it's generating in the back end. But your goal is to build what we call transformations, right? We want you to get the most out of Databricks, do that push on SQL, Spark SQL, and you do that with transformation jobs. What you're going to be doing is building out your folder and creating a transformation job. They'll tell you what to name it. Go say TX1 for my poor memory. And what you'll basically do is the first one will start off. You'll browse the Databricks environment. And in this case, I'm using 40. When you run these previous steps beforehand, what they'll do is create tables in Databricks for you. And what you can do then is browse the Databricks schema and pull the tables onto the canvas like that, right? And I think it's this one. One of them you're going to join twice is it's flights, right? So flights will be from the source and destination. The goal here is to figure out how many flights start from a certain place and end at a certain place, right? So we're tracking flights between Midway to Dallas or O'Hare to Las Vegas. And what you're going to do is self-join on that thing, on that table twice, because it has both source and destination, but the joins will be different. And what you'll basically do is once you drag these three tables on, you can sample them as you like, and then you're going to basically just join those three tables together, and the documentation will walk you through how to do that. But notice quickly how the platform is responding immediately to my actions, right? There's no compile, there's no, I spent 3 hours working on it, I cross my fingers and hope it runs. Any action that you do is immediately validated as you're working the pipeline. So that saves you a tremendous amount of time too, because you're real-time debugging and you're real-time sampling as well. So when you configure this join, ultimately it's going to tell you like, okay, what's the driving table, right? Any SQL join you need to have the first table, and then what do you want to join to, inner join, outer join, alias, that provide the expressions. And
So I think,
then eventually what you'll do is you'll create a rank.
Quick question, sorry. So I think when you're joining these tables, so does so the data is still in the data sources, right? It doesn't move the data somewhere else.
No, all of this is, so because if you look at this environments tab, right, there is a Databricks connection. If you were to edit your environment, you're going to see connection string information that are pre-populated for you to the cluster, and all this is happening in the cluster itself. So just for the folks that aren't aware, right, so the Delta format is essentially an array of Parquet files of the actual raw data. They're a bunch of flat files that then Databricks has then wrapped a JSON file around to have things like, hey, what has changed? It allows you to do things like time travel. If your table, right, which is essentially a file, has changed, it allows you to go back in time and all that stuff. So all this is all happening out of that S3 bucket. But it appears as a table that we're more accustomed to as BI developers or ETL developers, right? But the reality is that Databricks has found a way to leverage flat files as real tables without having to obfuscate into an actual SQL engine somewhere and copy that data twice. And that's where Sue was talking about. You're not going to maintain two copies because ultimately it's one copy. It's one flat file. It's a certain format that they've built, and built an entire, beautiful offering for, but we just leverage that as well. There is no Matillion SQL database that's running. It's leveraging commands through the compute cluster that's running on your Databricks engine and reading those same files that you just populated with our orchestration. So, I think we're at time. I don't want to hold you guys any longer. I'm sorry we didn't get through all of it, but as I mentioned before, I do want to just wrap up here. If there's any questions you have during the demo at your own time, you have my email. I'll share my contact information. But I did want to leave you guys here with two things, right? All of our academy is free. So if you have some genuine interest for Matillion, you can go to academy.matillion.com, and they have a bunch of free courses that you don't even need a Matillion instance because it's basically like an interactive pseudo environment that kind of shows you how to work through the screens. But it's all free for you to use. You just have to sign up for what we call a public account. And then we do have a certification program eventually if you were to adopt Matillion. And I did want to leave you guys with a special offering for the folks that are here. Let me just put that up there. So if you are in a position to maybe trial Matillion at enterprise scale or commercial level, we're offering you guys a free proof of value. You'll get about 2 weeks worth of free Matillion usage. We'll do what we call white glove installs. We'll walk you through making sure it's getting all set up and everything's up and running. And then we'll also credit you guys $500 in AWS for added costs to offset the cost of running virtual machines. So that's a special offer for you guys. It might be good. I know we're getting to the year end, so probably not, maybe an early Q1 initiative, but really standing up a virtual machine from an AMI or from the Azure Marketplace takes 30 minutes. We can have all the talks we need to, but I think you'll see a lot of benefits as you walk through the demo on your own time to see how easy it is to use. But unfortunately, I don't want to keep you guys here.
And I think, you had mentioned that you have tomorrow, Chicago Day.
Yeah. So we're also doing, coincidentally, I'll be downtown tomorrow if you guys are able to do the downtown at the AMC theater. So we're offering I'll find a link, but basically a free movie. We're going to see Avatar, so you're allowed to bring a colleague or spouse, so +1 to the event. It's going to be with our partners. You're going to have prospects there and current customers, so it might be a good way to network and figure out, hey, how's Matillion working out, or what have you heard about Matillion? We'll have some of our innovation partners there as well. So if you guys are interested, it's at the AMC over in River North, on the east side there by DDP. Where is that? Streeterville? Streeterville. Yeah. So we're off of Illinois over there. Yeah. So it'll be a good
What
event.
time is it?
It starts. I want to say it starts at 5, but then the movie starts at 7. So I think there's like an hour and a half of networking and presentations, and then the movie starts at 7, and there's like free popcorn and soft drinks. So I'll share that with you.
Yeah,
the link
please,
along with PowerPoint.
Share with me, and then I can send it out.
Yeah. Did everyone get a chance to write down the URL before I shut this down?
Yes, we
We're
are
all set.
connected.
Actually, I'm.
Okay. Well, thank you guys for your time. And like I said, any questions, feel free to reach out to me as well.
Thank you so much, Subbu. Thank you so much, Conrad. This was really good. Thank you so much, everybody.